Cool. Thank you so much for being here. So the name of the talk is trying to be really catchy, so it will be See It, Hack It, Sort It. We're going to talk about that a lot today. So first thing, who I am. I really love others. You're going to see that in the presentation, but I'm Brazilian, so that's my accent. I have been living in the UK for the past 4 years. I'm not from São Paulo. I'm not from Rio. I'm from the northeast of Brazil. That's my town there. That's called Campina Grande. And then we have the most big St. John's things in the world, which is strange because I think that we only have this kind of St. John's party in Brazil. But going through that, so the agenda is quite simple today. It's pretty much 3 things. See it, hack it, sort it. Really? No, we're going to have some intro slides to talk a little bit about GPUs, but pretty much I want to show problems, how you deal with that problems, and how you sort it out. First thing is some disclaimers. We did not harm any GPU doing that. They just get really hot, but that's the main thing. The second thing is our code base here was made in AI. I was testing some stuff, so it's quite good. So going through that. The main thing is most people know GPUs for games. I was playing one as a kid. I have these GPUs with 16 megabytes of memory that make me feel old. But why should you care? You don't play games. You don't think about GPUs for that stuff. 8% of the modern AI workloads run on GPUs. The other 20% will be in TPUs, tensors from Google, and FPGAs. But the main thing here is we talk a lot about that, right? Last week we talked about DeepSeek that use GPUs, to be fair. But why would you not understand how to deal that with our environment? How do we protect and attack that in a cloud-native space? So going that way, there's a lot of landscape for threats. GPU is another abstraction that you can use in the systems, even being a hardware, but there's a lot of things that you can explore. I think the most important is show that picture. If you read about threat modeling, if you read about attacks, you're going to see there's a lot of things quite similar to CPUs, but we're talking about GPUs and systems in overall. As we grow computer science, and that's the most beautiful thing, and that is one thing that software universe that's called linear algebra, you start to abstract. So the more that you abstract, you understand how you can see these things and understand how to play with them. Imagine that in these days, you need to understand the high and low of voltage, but it's so easy to have a coding language and then create more things. But thank you for understanding this, and let's start with see it. The main thing is, let's think about attack. The most common attack that we have these days is model poisoning. Model poisoning is, if I have a model being training for one thing, let's think one stuff that makes sense. So what I can change in a model that will generate any harm? And right now, I really want you to have this kind of offensive mindset, how I can do the more damage with a model. So to have in your mind, think about a healthcare system, right? So how you can attack a healthcare system and how much impact you can do with that. So I ask you guys to hold that thought, and we'll talk a little bit more about that. The risk of doing the kind of model poisoning attack is really high, because as you are training the model, you'll not be able to detect that something was changing that model. One thing that we see in LLMs is what we call hallucinations. But how you can differ what's a hallucination, what's true, and pretty much what was attacked there or not. And then we go to the most important part. How do you hack the thing? I really like to say that we are not isolated, right? You don't get a GPU and use only GPU. You don't get a desktop and just put the desktop aside. You have cloud, you have systems. So every single thing is a little big part of a bigger system. So that's why we use abstractions. And then for this presentation, a disclaimer is everything will be focused on the cloud, because most of the things that we are running a cloud, I work with Kubernetes, so we'll talk a lot about Kubernetes, but the main idea is we are not focusing on GPUs or just thinking at the desktop, which is really amazing. There's a lovely thing called side-channel attacks that I can talk about hours, but it's not for this talk. So let's think about, I have a GPU running in our on-premise, I have a GPU running in Amazon, GCP, or other cloud. And then think about Kubernetes. I really like the idea of abstraction, right? So you have CPUs, GPUs. But then when you start to think about GPUs in Kubernetes, it's just another resource. It will be too dangerous and too stressful to have a different thing for another part of hardware. So we create this thing that's an external resource. For that talk, for that first part, let's think that a GPU is just another resource, like a network adapter or the thing. And why this is quite important? Then we got the attacker path. Every single attack that you see in cybersecurity will focus on basic things. First thing, I need to find what I want to attack. The second thing, where's this thing? And remember that I told you guys, oh, think about healthcare systems. Imagine that you are using AI to detect cancer in people, right? Normally, we can separate cancer in two types, benign and malignant. So if I can change in the system and say that in the place of you have a cancer that's really easy to treat, I put that you have a worse cancer, or the other place. We have seen that in a lot of healthcare systems in the world. If you have a bad diagnosis, you can go through a path that don't make sense. So I can focus and say, okay, this person got a benign cancer in the place of a really bad one, and then they will not get treatment. So there's a place to attack and to focus. And all the path, the part of Hackett will focus on that. So how I can check the GPU. So a lot of things that people do is, I have a Grafana, I have some metrics, but that is open. So I can do a recon, which is a really simple technical for red teamers. And for that, I can scan, find the GPU. As abstraction, as I told you guys here, is just another resource. So I can see the tag of that resource, I can find that resource, and during this, I can create this attack. And then when I identify the training window, I can put another images. I can train my model to say what was good is bad, bless you, what is bad is good, and the main thing is I will have the data poisoning. So the main important thing here is if I understand what is my resources, how can I type my resource, I can change the output, and I can create a misdiagnosis. And then, okay, how do we sort it out? The main thing with this talk is see it, hack it, sort it, but pretty much how open source will enable us to protect GPUs. And then we have two things. We have Falco, and then we have Cilium. The main idea for these two parts is to check network policies, security policies, and from that place, how I can check and say, okay, I have a problem there. Just a little bit of code. So I try to protect my workload. And if anybody here work with observability or blue teams, the most important thing that we have are metrics. So if I train my system every single time from that and that and that computer, I send the request from that thing, why this other computer is sending things? So I can block them to do this really shady thing here of data poisoning because I know who is in my allow list, I know who is not in my own list. So there's some strange things. The other really amazing thing about hardware is they generate heat. So if you are changing your training, you are having things that okay, I have more power being used. I can check that was the normal behavior of the system. No, that's not the normal behavior of the system. So I can have some checks and understand that that's a problem happening. Somebody's trying to break my model. Other thing that's quite interesting about model poisoning is the first time this starts to happen, you destroy your whole flow of training. So how you can check that in a really smart way. The other thing is pretty much using Falco. Okay, I have spikes of use. So if I do a training and I have a lot of GPUs, okay, I will expect to have this threshold of performance, this threshold of use. There's something unusual there. Why are having more usage? So that's the little signs that you get that the whole information comes for you in a stack trace that you can sort it, understand, use the software, and sort out that problem. So attacking different GPUs, if you go all the way, you're going to say that's just abstraction. It's the same as another resource. So it's the same mindset that we have in the past for red teamers, blue teamers to attack and to defend. But normally, people only focus on the machine learning part. Okay, how do I protect that? But we are not alone. We are in a system. We are working for other things. So going from that perception, you can understand that if you are protected of infrastructure, we will be able to use open source software and then protect the whole things. So that's one of the aha moments. The other quite things like, okay, we got the first one. So here you go, boy. Let's have another one. Pretty much going on the seat is memory. Memory is the most unbelievable great thing about GPUs and the most stressful one. So if you have been working Incident Manager for the past 10 years now, every single time if you work with AWS, GCP, we'll have somebody trying to attack you, try to put a crypto mining bot, use infrastructure, and then try to get some money of that. It's the less favorite thing for a CloudSec person, but I quite love this kind of attack because it's simple and it's really easy to see happening. So think about GPU. GPU memory going really fast is the idea of having a unified memory is because you're going to expand your performance, things will be better, the communication will be okay. But like everything in life, this creates new security risks, this creates new problems. So how we can sort it out this, that we already start to see the problems there. Still on the seat, memory looks tasty, but at the moment that I have compartment memory, I can compromise one point, and then I can do one thing that's a really old attack, there's a buffer overflow. So pretty much, if I can attack up the pages, if I can attack the memory table, I can put another information there. I can do a different type of attack. And I can do the thing that everybody loves to do, that's pretty much steal your resource. If I steal your resource, I can run crypto mining. I can run any other thing. But you folks can see that the main idea is still how I can do some recon, how can I discover some things, how I can get the resources, and how I can explore the GPU as a really expensive thing that you do things for me. And then pretty much solid, right? The most lovely thing that we have is metrics. And GPUs give you a lot different of things. I really love to talk about power because energy is a really expensive resource and it's really easy to check because you're going to see the difference in voltage and so on. So with that metrics, we can check there's an anomaly. There's somebody, okay, my energy bill for my GPU farm is cost like 500K per year. Why is costing 200K per month? So from that little signals, for that little information, you can start to discover things, create attacks, and sort it out. And then we can use things like Falcon Kuba Armor. That's pretty much the same thing about policies, but creating things like, okay, the energy is going off that threshold. How can I sort this out? I have network policies. Why this thing is coming from North Korea? Why this thing is coming from another country? So it's pretty much more of the same. We talk a lot about security, but I think that's the most important part. If you know the basics, you can expand for a lot of different contexts and then still be able to deal with that and improve. I really like to talk about more theoretical examples. We have a lot of things in the threat landscape, but I really to try things to be more real. When I was doing this talk last week on Monday, the 27th of January, NVIDIA launched 7 new CVEs. God, I have one thing for CVEs because I find they quite amazing. And the main idea is, if you have these and the whole information of the system, you can understand and learn from that. So think about, again, of the CIT. NVIDIA launched the 7 CVEs. I'm going to pick one of those. The one that I picked was Virtual GPU Manager. And the main idea, again, is how do you corrupt the memory? And inside of that, how we can think with what we learn right now in these really 3 easy steps, how I understand what's my main problem, how I can attack that in different ways, and pretty much how we grow with that. And then going to the Hackett, we got this really big image. So from the CVE, we can do different attack paths. We can attack memory, we can attack access control, we can attack resources, right? And then you have 4 big damages. You can have data tampering, info leak, a denial of service, and pretty much code execution. Code execution is the most beautiful thing that an attacker can do. If you run CTFs, did you work with CTFs, if you are a red teamer, when you got a reverse shell, your heart just blooms. The main thing is I can run anything that I want on that infrastructure. So doing this, I can request resources, I can allocate memory, and then I can do execution of my code. So if you look about that example and focus on the memory one, and the first one with the memory poison, sorry, the model poison, you have the same flow, but it's pretty much the same kind of attack that we did in the past for CPUs, the same kind of attack that we did in the past for servers that are not in the cloud, and so on. And then it's kind of the same slide, but it's not the same. You still have the same protections, right? So one thing that I used to say when I was working with one CI/CD hacker, he used to say that most of the problems are quite the same. We think in putting new things because you need to push new features, you need to push new things, but we do not think in put the really simple gatekeepers. So the logic to prevent this kind of attack, there's a now CVE that was launched last week, is using Falcon Kuba Armor to have the policies and to understand what's happening with your system, with the metrics, and so on. I quite love that's a new landscape, right? Even looking a little bit of the same, GPUs came to stay. Like every single time we talk about ML, we talk about LLMs, and then especially we have the whole thing with DeepSeek 2 weeks ago, and DeepSeek was still using GPUs. So you have this new landscape that we try to abstract and create the views for the future to be close to us, to be close to the things that we use. And I think the most important catch-up is if you do not evolve security in the place that people will be able to use in a nice way, they will find a way to do the things with the expense of security. I really advocate for the idea that how much close you put security for developers, how more close you put security for the whole platform engineering bit will be really easy to help and to focus on the problems that we are getting right now, that's pretty much the same problems of 3, 4, 5 years ago, even with the whole AI booming different things. A GPU is just another resource in a thing that we're using a lot. So that was 2 main slides. So I really hope that you understand that, okay, GPU is quite important, they are coming to stay, so how I can evolve that. One thing that's quite nice about GPUs, I did start to work with GPUs for the first time 15 years ago, is we still do not know how to program GPUs, how do you program CPUs, because you use things like CUDA, so how do you evolve that, how do you code that runs really well with GPU, especially because you got a different paradigm, right? You got parallel computation, that's not the same as the computation that you use right now. And pretty much, we just need to go to the basics. We have 2 softwares pretty much think on syscalls. There's the same things that we have been talking about OS for the past 50 years now. And that's why we said a lot today. See it, hack it, sort it. Any questions? Oh, I love others. Any other questions? Thank you so much.